Okay. We have discussing reversible reaction, and in the last class, we discussed Lee-Chatelier principle. And Lee-Chatelier principles basically states that if there is any change which actually disturbs the position of equilibrium, so equilibrium shifts in a direction to minimize that change. So remember this concept that for a reversible reaction, if there is any change that occurs, according to the Lee-Chatelier's principle, our reaction proceeds either forward direction or backward direction, but the objective of that reaction to be proceeded in either forward direction or backward direction is to minimize that change. For example, we have ended the class over here where we have discussed about concentration. And what we have discussed, we were doing reversible reaction. That, for example, if there is a reaction in which, for example, these are the reactants which are converting into a product and there is a product C. When the equilibrium is established, what does equilibrium establishing means? It means that it is the point where both the speed of forward and backward reaction becomes equal. So when the speed of forward and backward reaction becomes equal, now there will be no more product form because the way the forward reaction is taking place, the backward reaction is also occurring with the same speed. So when both the reactions are occurring with the same speed, then what will happen? That there will be no more product form and no more reactant used up. So whatever the reactant left when the equilibrium is established, that amount of reactants stay over there, they do not further used up. And in the same way, the product which is formed does not further formed. Is this understandable? So, for example, the equilibrium is established. Now think of this situation. At equilibrium, there are 3 moles of A, 3 moles of B are there, and 6 moles of C are there. So this is the position of equilibrium. So if, for example, if I add either one of the reactant in this position, so what I did, I disturbed the equilibrium because the equilibrium only establishes when the reactant and product are in the ratio of 3:6. Is this understandable to all of you?
Yes, sir.
So, for example, let me write it over here that a reversible reaction where A and B are reacting and they are turning into a C, and at equilibrium, there are 3 moles of A, 3 moles of B, and 6 moles of C. So it is the equilibrium position. Okay. Now what I did, let's suppose I have added 6 moles of both reactants. So this is the new situation. If I have added 6 moles of both the reactants, then what will happen now? Instead of 3, there will be 9 moles of A because 3 moles are already there and I have added 6 more. 9 moles of B and 6 moles of C. So what do you think that now it will stay a same or some change occur?
Sir, change will occur.
Okay, good. What change will occur? See, the equilibrium is this. So actually what happens, which concentration is changed? Reactants concentration is changed or product concentration is changed?
Reactant.
Reactants concentration is changed. And what is this change? That change is increased concentration or a decreased concentration?
Increase concentration.
So just recall the Lee-Chatelier principle. What is it states that equilibrium shifts in a position to minimize the change. So the change over here is increased concentration of the reactants. So equilibrium try to minimize this change. And how could this change be minimized when the equilibrium shifts to the forward direction or shift to the backward direction?
Forward.
Direction, because there are excess reactants. So the reaction occurs in a forward direction. So all of the excess reactants turns into product, and again the equilibrium will establish. Is this understandable? Okay.
Yeah.
The same way, if, for example, I have decreased the amount of product. For example, at equilibrium, they are existing in the ratio of 3:6. So what I did, I remove all the product. So now what happens? The decreased in the product, the changes decreased in the product. So what will happen next? Where the equilibrium shifts, forward direction or backward direction?
Forward.
Forwards, you are saying backwards. Why? What I did, I removed all of the product. So if the product is removed, so the amount of product is decreased, right? So we have to minimize this change. So it means we have to make sure that more product will form. So how will more
Yep.
product will form when the reactants again turn back into the
Product.
forward direction and will form more product? Yes, if I decrease some of the reactants, then the equilibrium shifts to the backward direction and backward reaction occur. Or for example, instead of this, if I keep the reactant same, but I, let's say, increase the product. So see, the product is 6 at equilibrium, but I have added more of it. So what will happen? That the equilibrium shifts to the backward direction.
Backward
So
direction.
the excess amount of the product and react and form reactants. So there will be again equilibrium. Is this understandable? Yes, did you
Yes, sir.
understand? Okay. Now, after this, next factor is a temperature. So what it states that whenever, okay, see, for example, consider this.
Sir.
Yes.
Sir, hello.
Yes.
सर ये रिएक्टेंट्स इसमें 9 9 होते हैं ना? I mean प्रोडक्ट जो होती है वो 9 + 9 और
No, for every reaction it always differ. Okay.
Okay, sir.
Okay. So for example, this equilibrium is established at temperature of, let's say, 25 degrees Celsius. So equilibrium is always, aligned with the temperature as well. So what I did, after some time, I provide heat to the mixture, and as a result, the temperature is to 50 degrees Celsius. So actually, what change occurs now? What is the change?
Temperature.
Temperature. And what change it is? Increased temperature or decreased temperature?
Increasing.
Temperature. So according to the Le-Chatelier principle, the excess temperature would be, decreased, because equilibrium states that the Le-Chatelier principle states that equilibrium shifts in a direction to minimize the change. So we have to decrease this excess energy. So which reaction is there which, absorbs energy? Can anyone recall?
Endothermic reaction.
Endothermic reaction, we have studied there are two types of a reaction, endothermic reaction and then
And
exothermic reaction. So there is a excess energy because the energy must be 25 only. So there is a excess energy. So equilibrium shifts in a direction in which energy is absorbed, and the reaction where the energy is absorbed is called endothermic reaction. So this is the rule over here. When we increase the temperature, equilibrium shifts towards endothermic reaction. Now we have to identify that whether a forward reaction is endothermic or a backward reaction is endothermic, and how we identify it. For example, if over here they always give you a delta H value, or they have tell you in the statement whether it's an exothermic or endothermic reaction. If the positive sign is there with the delta H value, it means that forward reaction is endo, and whenever the forward reaction is endothermic, the backward reaction is exothermic reaction. Is this understandable?
Yes, sir.
Okay. Now, In the same way, when the delta H value is negative, it means that the forward reaction is exo, and if the forward reaction is exothermic, it indicates that the backward reaction is endothermic. Okay. So remember, whenever we increase the temperature, equilibrium shifts to the endothermic side, and we have to decide whether forward reaction is endothermic or the backward reaction is endothermic. And if we decrease the temperature, equilibrium shifts towards exothermic reaction. Now we have to decide whether the forward reaction is endothermic or the backward reaction is endothermic. Okay, complete this temperature factor, then we will discuss about pressure. Yes, Khatija.
Assalamualaikum, sir. Sir, I have a question that only when the reaction will be forward reaction and it is endothermic, and if we are increasing the temperature, so only then the equilibrium will shift towards the right. Am I right?
Yes. Yes, because for when the forward reaction is endothermic, then whenever we increase the temperature, the equilibrium always shifts to the right. And if the backward reaction is endothermic, so whenever we increase the temperature, equilibrium always shifts to the left.
Okay, sir. Thank you.
Is everyone done with the temperature?
Yes, sir.
Okay. Next, we have a pressure. So remember, pressure is only affect the gases. So pressure can be applied to only those reactions in which gases are present either on the reactant side or on the product side. And whenever we increase the pressure, equilibrium shifts towards the side where there are lesser moles of gases, whether reactant side or product side. Okay. So whenever we increase the pressure, how the pressure could be increased? Yes, how can you increase the pressure?
By decreasing the volume or
By
decreasing the temperature?
yes, good. By decreasing the volume, actually, when we compress something, then the pressure is always increased, right? So when you compress it, you actually makes less space available for them. So as a result, equilibrium shifts to the direction, whether forward or backward, on which side there are lesser moles of gases. And whenever we decrease the pressure, it means that we allow them to spread in a more bigger space, and that's how you can decrease the pressure. So whenever you decrease the pressure, the space in which they can, they can be present is actually increased, and as a result, equilibrium shifts in a direction where there are more moles of gases. So you have to figure out by the chemical equation on which side there are more moles, whether the reactant side or the product side. Is this understandable to all of you? Yes, Laiva.
Yes, sir.
Okay, yes, Khatija. Aisha, Amir, Aisha, Usman, is it understandable? Mujtaba, Mustafa, Saad, is it understandable?
Yes, sir.
Yeah, sir.
Yes. Manahil, did you understand? Then after this, we have a catalyst thing. So if you guys recall, catalyst speeds up the reaction, right? Catalyst is
Yeah,
something
enzymes.
which speeds up the reaction. So catalyst does not affect the position of equilibrium. It does not affect how the forward or the backward reaction occurs. When we add catalyst, equilibrium establishes more quickly. That's it.
सर जहाँ लेस मोल्स होंगे वहां पे इक्विलिब्रियम शिफ्ट होगा ना?
If we increase the pressure,
ओके सर.
and if we decrease the pressure, equilibrium shifts where there are more moles. आप लेट क्यों हो गए भाई इतने? थोड़ा जल्दी निकल गए।
Sir, can you please scroll a little upside?
Is this fine?
Yes, sir. Done, sir.
Sir,
Yes, Khadija. Yes, Mustafa.
sir, ये हर जगह फॉरवर्ड और बैकवर्ड क्यों लिखा हुआ है?
Because we have to figure out on which side where there are lesser moles or where there are greater moles.
ओके सर.
सर मैंने आपको PDF का बोला था सर.
Sorry.
सर मैंने बोला था PDF सेंड कर दिए ग्रुप पे.
Yes, after the class I will share it. Yes, completed.
Yes, sir.
Yes sir.
Okay. Yes, Rohit.
सर हम ऑर्गेनिक कब स्टार्ट करेंगे?
After reversible, we will do moles and then we will start organic.
And sir, P4.
In P4, okay. In which question you are facing a problem in P4?
Sir, in planning questions and in most
Sorry.
questions. In planning questions and in most questions.
Okay, the
And
mole
when they
questions
ask,
are covered with the moles, then we were left with the planning question that we will do later. Yes.
okay.
Done?
And sir, वो जो ये पूछते हैं कि suggestions मांगते हैं कि अब क्या करना चाहिए if you think to improve this वगैरह ये सब कुछ.
Okay, I will guide you about this.
Okay, sir.
Okay, let's have a look at some questions of this reversible reactions. So these are three factors: concentration, pressure, and temperature, which can shift the position of the equilibrium. Catalyst will not just only speeds up the reaction, it will not shift the position of the equilibrium. Now, have a look at this question. See, the arrow in the equation shows both directions, which means that it is a reversible reaction. So the question always comes combined. Whenever they ask you about the reversible reaction, they also ask you about the rate as well. So you have to keep the things clear, that whether they are asking about the rate or whether they are asking about the reversible reaction. So if you see, look at this question, that the concentration of ethanoic acid is increased. Okay. So what they are told you, that the concentration of ethanoic acid is increased, and over here propyl ethanoate is prepared. So it means that it clearly indicates that this is your product. By the reaction between ethanoic acid and propanol, so it means these two are reactants. Is this understandable to all of you?
Yes.
Yes.
Yep.
Is this clear? Okay. So the concentration of ethanoic acid is increased. So ethanoic acid is what? Reactant or a product? It's the reactant. So it
Reactant.
means we are increasing the concentration of someone from here. Now, read the first part. In the first question, they are asking, state and explain in terms of particles what happens to the rate of forward reaction. So in this part, they didn't ask you about the equilibrium. They ask you about the rate. Okay. So these two are the different thing. Now, if you look at the next part, two, the water formed in the reaction is removed. State and explain what happens to the position of equilibrium. So see, if you look at the equation, where water is present, on the reactant side or on the product side?
Product.
Product side. And what you are doing with the water? You are removing the water. So it means you are removing the concentration of or amount of one of the product. So if one of the product is removed, then on which side equilibrium will shift? Equilibrium will shift to the right or to the left?
To the right.
Why left? If you are removing this thing, so forward reaction occur further to make the water more, because it is decreased. So which thing is, if the reactants are decreased, then equilibrium shift to the left. If the reactants are increased, then equilibrium shifts to the right, because there are more reactants. Now, as we remove the water, the amount of water is now it becomes lesser. So to make more water, what will happen? Equilibrium shifts to the right. Is this understandable to all of you?
Yeah.
So what I'm going to write over here, see, they ask you what happens to the position of the equilibrium. So we will write that the position of equilibrium shifts to right, and see how much marks it has. 2. So this will, if you just state this, you will get only 1 mark. Second mark, you have to explain why it is shifting to the right. So I will
Sir,
add
due to H2O reaction.
because Yes, what you were saying?
सर वाटर रिमूव हो गया था रिएक्शन में इसलिए.
Okay, good. Because water is removed. So what was the Le-Chatelier principle? States that equilibrium shifts in a direction to minimize the change. So to replace the removed water, so whatever the water that was removed, we have to replace it. So if the reaction occurs in the forward direction, more water will form, and whatever the water which was removed, it will form again. So to replace the removed water. Is this understandable? If any one of you has any query, any question, please ask. And whenever they remember, see, they have mentioned you have to explain in terms of particles what happens to the rate of forward reaction. So when there is a more concentration, how the molecules are arranged, they are closer to each other or they are further away from each other?
Closer to you.
Sorry? They are closer
can you
because
Closer.
concentrated means there is a more amount of solute. So when they are closer, what happens to the particles collision? They will occur more frequently, or it will occur less frequently.
more frequently, sir.
Very good. If it will occur more frequently, then what will happen to the rate? The rate will
It will
increase. Very
increase.
good. So that's how you will formulate the answer. As they say that the constant, if you see over here, concentration of ethanoic acid is increased. So you will write increased concentration means more number of moles per unit volume. Hence, or instead number of moles, you may write number of particles per unit volume. Hence, more frequent collisions occur.
सर यूनिट में डेसीमीटर क्यूब आ सकता है.
Yes, and rate of forward reaction would increase. Now think, if instead of this forward, examiner have used the term backward, then what will you write? No, that is the trick which examiner played over here. Whenever we are talking about rate, it doesn't matter whether the forward or the backward reaction, rate would always increase when the concentration is increased, rate would always decrease when the concentration will decrease. Decrease in concentration means lesser number of particles in a specific volume, which means particles are further away. And when the particles are further away, they will take
Rate
more
of
time
reaction
to
would
collide, so the less frequent collisions and the rate would decrease. So it doesn't matter whether the reaction is forward or backward, the rule is same for the rate. It matters only when you have to choose the position of equilibrium. Is this understandable?
Yes, sir. सर ये जो सेकंड क्वेश्चन में आपने ये लिखा है सो टू रिप्लेस द रिमूव्ड वाटर लाइक वाटर तो रिमूव हो रहा है ना तो रिप्लेस से समझ नहीं आई क्यों लिखा.
So it means that there is a decrease in water concentration, right? In part 2. So
Yes.
Le-Chatelier states that equilibrium shifts in a direction to minimize the change. So the change is what? Decreased concentration. So when the forward reaction will occur, so whatever the water that is removed will form again.
Okay, sir.
Okay.
सर मुझे पहला वाला समझ नहीं आ रहा सर थोड़ा बहुत.
And first, what they ask you, they just informed you that the concentration is increased, right?
जी.
So you just go through the notes of the rate of reaction where we have discussed when the solution is concentrated, it means there are more particles in a specific volume. And when there are more particles in the specific volume, they are closer to each other. And when they are closer to each other, they will collide more frequently, because when they are closer, they require lesser time to reach to each other. So they will collide more frequently. And when the collision are more frequent, then the rate would be higher.
अगर less concentrated होगी सर तो rate of reaction slow हो जाएगा.
Yeah, why? You have to again explain in steps. If they have said, for example, here they have said the concentration of ethanoic acid is decreased. So we will write that decreased concentration means lesser number of particles per unit volume. And if there are lesser number of particles, which means the particles are further away from each other. So as a result, the frequent collisions are not that much frequent. The collision occur less frequently. And when the collision occurs less frequently, then the rate would become slower. Is this clear now? Okay. Now see,
जी.
have a look at this reaction. Again, what if you read the statement, you can easily identify which thing is a product and which thing is a reactant. Methyl propanoate is prepared. So it means methyl propanoate is reactant or a product? Product. By the reaction between propanoic acid and methanol. So it means these two are
Reactant.
reactants. The forward reaction is exothermic. So see, they have told you now that the forward reaction is exothermic. If the forward reaction is exothermic, which clearly indicates that the backward reaction will be endothermic. Now, if you read the first part, the temperature of the reaction mixture is increased. Explain in terms of particle what happens to the rate of forward reaction. So see, again, they didn't ask you about the equilibrium, they ask you about the rate. So when we increase the temperature, what happens to the particles?
सर वो बहुत ज़्यादा like vibrate
First, what
करते
will
हैं.
happen on increasing temperature?
Rate of reaction increase.
Obviously, that is the final thing. But what happens when you increase the temperature?
सर vibrate करते
The
हैं
kinetic energy
atoms.
of particles with increased particles gain energy. If the particles have a higher energy, then what happens to the collision? If they have a higher energy, they will collide more frequently or less frequently?
More.
Frequently. And when they collide more frequently, what happened to the rate? Rate will increase.
Increase.
You have to move step by step from the scratch. When you increase the temperature, think what happens to the particles. Obviously, particles gain energy. When particles gain energy, it means now particles have a more energy than the previous temperature, which leads to more frequent collisions. And when there are more frequent collisions, the rate will increase. Okay, now, next part, the temperature of the reaction mixture is increased. Okay. Explain what happens to the position of equilibrium. What we have decided in class, when we increase the temperature, in which direction equilibrium shifts. Just check in your notebooks, you have noted down today only.
Sir, endothermic भी मारेगा ना sir?
Yes. Yes, Manahil, when we increase the temperature, where the equilibrium shifts? Towards endothermic side. That's what we have right. See, and here they have stated you that the forward reaction is exothermic. If forward reaction is exothermic, which clearly means that the backward reaction would be
Endothermic.
And we know when we increase the temperature, equilibrium shifts towards endothermic side. So see, in this part, state and explain what happens to the position of equilibrium. So I will write that the position of equilibrium, yes, where it will shift backward or forward?
Backward.
Because our backward reaction is endothermic. So the position of equilibrium shifts backward. That will get you 1 mark as backward reaction is endothermic. Is this understandable to all of you? समझ में आ रहा है?
Yes, sir.
कि अगर किसी को कोई कंफ्यूजन है, कोई क्वेरी है तो पूछ लीजिए. ओके. Now have a look at this one. When calcium carbonate is heated in a closed container, an equilibrium mixture is formed. Again, they have told you the forward reaction is endothermic. If forward reaction is endothermic, it means now backward
Backward is
reaction would be
exothermic.
exothermic. Describe and explain the effect, if any, on the position of equilibrium when a hole is made in the container. Yes, any guesses? What happens when there is a hole in the container? Yes, Laiba.
The temperature will increase.
What? Can you repeat?
The temperature will increase because
How the
the
temperature will
Yes.
increase by making the hole? What? No.
because the temperature is
Sir, the
Body of
position of
decay to जाएगा.
equilibrium will go towards the exothermic.
See. Okay, look at the states of the reactants and product. What is its state?
Sir,
Solid.
pressure will influence it.
What is its state? What is its state?
Solid.
Gas. So
solid.
when you put a hole, what happens to the gas?
Sir,
The
वो
gas escapes, right?
escape.
Yes.
And if the gas escapes, it means that the concentration of carbon dioxide is decreased. See, that's how examiner asks you. Examiner never always see the timing, please. So see, if the hole is made, it means that whatever the gas is in the container, that all gas escapes. So if the gas escapes, it means the concentration of that gas is decreasing. So equilibrium shifts in a
Then
direction to make that
forward.
gas again and again. So that gas is on the product side, right? So it means that the product concentration is decreasing, and if the product's concentration is decreasing, then where the equilibrium shifts, to the forward, to the right, or to the left? To the right.
Right.
Very good. Is this clear to all of you?
जी.
Okay. So I will write the carbon dioxide escapes and its concentration decreases. So the equilibrium shifts to right to replace the escaped CO2. Is this clear?
Yes, sir.
Yes, Aisha, Amir, Aisha, Usman, Mujtaba, Mustafa, and Saad.
Yes, sir, it's clear.
Yes, sir.
क्वेश्चन पास पेपर के या
Past paper.
सब कौन सा है
Year नहीं पता.
सर आप अपनी फाइल शेयर कर देंगे टॉपिकल्स की.
Okay, now describe and explain the effect, if any, on the position of equilibrium when the temperature is increased. So if we increase the temperature, equilibrium shifts towards why?
Right.
Because the forward reaction is
Because
endothermic in this case.
yes.
Position of equilibrium shifts to right as forward reaction is endothermic. Is this clear to all of you?
Yes, sir.
जी sir.
Okay. Moving on question. Okay, now have a look over here. A scientist heats a sample of phosphorus 5 chloride in a closed container. A dynamic equilibrium is established. So remember, whenever there is a gases, either on the reactant side or the product side, we always choose a closed container to establish the equilibrium. Otherwise, if there are a gas, they can easily escape, so the equilibrium would not establish. What is meant by the term dynamic equilibrium? Who can tell me this? Yes, the one who present in the last class. Manahil, you were there in the last class. What does dynamic equilibrium mean?
When the forward reaction and the backward reaction is same.
When
When the forward reaction and the backward reaction is same.
no, it's the
Sir, when they are balanced.
No, not balanced. You can't say balanced. Yes, Laiba.
The rate of forward reaction and
Yes, the
backward
rate of forward reaction and the backward reaction is same for a reversible reaction. So you can write a reversible reaction in which rate of forward and backward reaction gets equal or same, then that point is called reversible reaction. Oh, sorry, that point is called dynamic equilibrium. So sometimes what a student do, student just write when the reactants becomes equals to the product, it's a dynamic equilibrium. No, it's not. When it's balanced, forward and backward reaction is balanced. No, it's not. You have to specifically state that dynamic equilibrium is the position when the speed or the rate of forward reaction becomes equals to the rate of backward reaction. That is dynamic equilibrium. Is this clear to all of you? Now see, next part. The pressure of the equilibrium mixture is increased. So where the equilibrium position shifts when we increase the pressure?
Right.
Forward.
Sorry?
Forward.
No.
नहीं सर जहाँ पे मोल ज्यादा होते हैं वहाँ पे.
No, that is about temperature, not pressure. Here we are increasing the pressure. Yes,
Sir, where
यहाँ पे
the
we have a
gas-
lesser moles of what? Gas. Pressure increase shifts the equilibrium where there are lesser moles of gases. Pressure decrease shifts the equilibrium where there are more moles of gases. Predict and explain what will happen if anything to the composition of the equilibrium mixture. So if you see the equation again, how many moles of PCl5 are there?
One.
One, because there is a no coefficient, which means 1 mole. If there is a coefficient, that means that are the number of mole. So there is a 1 mole. And how many moles of PCl3? 1. How many moles of chlorine? 1. So in total, if you see here, 1 and 1 makes it 2. So there are 2 moles of gases on the product side, and there is a 1 mole of gas on the reactant side. So which side has a lesser mole? The reactant side. So if
Reactant
I
side.
increase the pressure, where the equilibrium shifts, right or left? Left, because the reactant side or the right hand side has a lesser moles of gas. Is this
सर
understandable? So you have to look at
सर ये आप
yes.
सर ये आप बताएंगे पीसीएल आपने कैसे पता है कि मोल्स वहाँ पे एक है क्योंकि आपकी आवाज लैग हो रही थी सर समझ
Is
गया
there any coefficient written before these reactants and products?
नो सर
It means that there is a 1 mole of this, 1 mole of this, and 1 mole of this. So if the on the reactant side we only has 1 mole, And on the product side, in total, we have on 2 moles of gases because both are gases, right?
Yeah.
So which side has a lesser moles?
Reactant.
Reactant side. So equilibrium shifts to the reactant side, to the left side when we increase the pressure. Is this clear? Okay. So
Yes, sir.
prediction will be the position of equilibrium shifts to the left.
सर टेम्परेचर जहाँ वो टेम्परेचर वाला बताएंगे इक्विलिब्रियम कहाँ शिफ्ट होता है जब टेम्परेचर ज्यादा
On increasing temperature, equilibrium shifts to the endothermic side. We discussed 2 questions.
या सर सॉरी
Okay. To the left. And if I talk about the concentration of these, what happens to their concentration? Their concentration would decrease or increase. If you are guys are saying the equilibrium is shifting towards, when we increase the pressure, where the equilibrium is shifting? To the left,
रिएक्टेंट
to the reactant side. So what will happen to their concentration? For example, if I am talking about their concentration, what will happen to their concentration?
डिक्रीज होगी
Decrease. And what will happen to this concentration?
इंक्रीज
So see, if you look over here, they just didn't ask you the position. They actually highlighted it that you have to predict the composition of the equilibrium mixture. So I will write that PCl5 concentration increases if I'm writing in context of this one. But if I'm writing in this in the context of this one, I would write that the concentration of PCl3 and chlorine will decrease.
विल डिक्रीज
So that is my prediction. Now explanation. As there are fewer moles of gas at right hand side or reactant side, hence equilibrium shifts to left. Is this clear to all of you? Okay. Now,
सर इसमें प्रेशर वाली बात तो समझ में आ गई लेकिन कंसंट्रेशन वाली बात समझ नहीं
जी सर
can you repeat again?
आई इस क्वेश्चन में प्रेशर वाली बात तो समझ में आ गई बट आपने कंसंट्रेशन वाली बात लिखी ना वो समझ में नहीं आई
See, if you read what they are asking you, what will happen if anything to the composition of equilibrium mixture. They didn't actually ask you about the where the position is shifting. They ask you what happens to the composition. So composition, what does composition means? Composition means what are the contents present in it. So when the equilibrium is shifting to the left, it means more amount of reactant will produce and the amount of the products will decrease because equilibrium is going to the backward direction. So that's what I have to write it over here.
ओके सर
And then we have to explain it. Yes, is this clear?
सर
Okay.
लेकिन ये कंसंट्रेशन इंक्रीज कैसे हुई
So we will be ending the class over here. In the next class, we will do the Haber process and the contact process.
सर हेर्बर प्रोसेस आयरन वाला होता है अमोनिया
Iron is the catalyst to form ammonia. Okay.
ओके
Okay, take care, everyone. Allah Hafiz.
अल्लाह हाफिज